For this example, we're going to determine if the following argument is valid. In part A, if Mr. Scott is still with us, then the power will come on. The power comes on, and then we have the line there with the term for the following sentence. Therefore, Mr. Scott is still with us. It means we are going to translate from the English sentences here into the symbolic form. First of all, we're going to define the simple statements by letting P to represent Mr. Scott is still with us. Statement Q represent the power will come on. The power come on, that's the same as statement Q. Mr. Scott is still with us, so statement P. So we have two simple statements. The symbolic form, the first sentence has a conditional connective, like if then. So we write it as if P then Q as the premise number one. So this is premise number one. Premise number two, the power comes on. The power comes on, that is the statement Q. Draw the line, and therefore, that's a conclusion. Conclusion, let's put the three dots, and that means, therefore, Mr. Scott is with us, which is the statement P. We got the symbolic form. And this is the premise number two, and this is the conclusion. The compound statement, the premise number one and premise number two all together in one bracket and work it as the antecedent and a consequence, which is the conclusion or the statement P for this example. Now we have the compound statement. So what we have to do, we're gonna build or construct the truth table, and the truth table that we're gonna form, we're gonna need the column for the P, statement P, statement Q, column for P, then Q, the column for P, then Q, and Q. And after that, build another column for the compound statement for this argument, for the column for the P, then Q, and Q, then P. That means we're gonna need to construct 1, 2, 3, 4, 5 columns for the truth table. As you see on the truth table, we're gonna need P then Q, P then Q, and Q, because this is the premise number one, and this is the premise number two. Connect with the and then the conclusion is the P all together, and the last column is the column for the argument. All right. For the first column, P then Q, the if then the antecedent true, then the consequent false will return false. Otherwise, you're going to get the true value. So P then Q, true then true, that's true. True then false, this is the case that return false. The rest will be true and true. Next, P then Q and Q. So I'm going to create the little column like next to this as a Q. The Q column has T, F, T, F, and we're going to do the and. So and. The result for the and or the connective, the conjunction, when both of them are true, the result will be true. The rest of them gonna be false. So true and true gonna be true. False and false, just gonna be false. And the next is true. The last one is gonna be false. Now, the connection for the premises are done. The last column is the one to find the truth value of the argument. We're gonna use the one we just found and connect with the conditional statement if then with the column P. For our convenience, I'm gonna create the little one here for the column P. Column P has true, true, false, false. With the if then or the arrow, the arrow means antecedent true, consequent false, or true then false, the result gonna be false. For the first combination, true then true. So this is a true. You see, this is the main connective. So I write the result aligned with the if then symbol. False and true. So this is true. True then false. This is the case that you're gonna get false statement. False and false can be true. The third combination make it not valid because it's not a tautology. So therefore, this argument is invalid.